Hello guys, welcome to my channel. Today we are going to see a problem on binary search which is related to array and binary search. So it is kind of using logic of binary search over array to solve this problem. So let's see what exactly problem is. Today's problem is problem number 977, which is squares of sorted array. So here it is not a normal array. It contains negative number as well positive numbers, but the array is sorted. So that is the special case of this array, that it contains negative number as well but it is sorted. Okay, but the output array should be again sorted one, right? Non-decreasing means increasing order. Okay, so here -4, -1, 0, 3 and 10, then output should be like 0, 1, 9, 16 and 100, because if we find the square of negative number then it will become positive, and then the challenge is that the output array should be positive. Then we have to accommodate this change, that if the number is negative as well, still we have to make it sorted in the output array. So for example, let's say we have 1, okay, then we have 2, and we have mm, sorry, we have, let's say, -9, 1 and 9, 1 and 2. So then output array, whether this is sorted, yes, this array is sorted. So now output array should be like 1, square of 1 will be 1, square of 2 will be 4, and square of 9 will be 18. Correct? Negative into negative, it will become positive. -9 into -9, it will become positive 18. So in this way we have to accommodate. So logic will be, we are using binary search kind of approach. That means we are using two indexes, one at the start and one at the end, and then check if whichever index is greater, then that index we will put into our array, and we start putting the element from the end, so that our output array will become sorted. So let's see how we are going to solve this. So what we need, first we need to take the size of array. Let's say int n nums dot size. This will give the vector size. Okay, then we need to position int I start is equal to 0, int i int I end is equal to, we want to start from the last, but since array index starts from 0, that's why n minus 1. Okay, and then current position, we start inserting element into the output array. That position we indicate by using this position. Okay, let's start by putting element from the end. So for that reason we need one output vector, so we have to return output vector, right? So we declare that output vector as well. Let's call it as vct rate. Vct for vector, rate for return. Okay, but we want basic initialize with its default size, that is 10. Okay, now we will do while. What we usually do, we do in binary search, we run the loop till both indexes crosses each other. Similar way we have to do this. We need to check whether I start is less than I end. Okay, I end. In this way we will run the loop, and once this loop is completed, then we should have the sorted return vector. Okay, we city rate we will return. Now the actual logic is here. So we start putting the element from the end, but which element we have to consider? Okay, so since array is sorted, but it can contain negative number, so to accommodate that, we have one absolute different function. We have one absolute function from standard C++. So we are going to make use of that, where the absolute value of nums of I start, okay, if it is greater, absolute value of nums of I end index, I end index. Okay, we have to write inside this into inside if. Okay, so if the absolute value of this is greater, that means current element is eligible to put inside the array, because we are putting element from the last. Okay, so the output element will be in the VCT rate of which position we are going to put it in the position. Okay, and what number, square of the current number. So currently start is greater, so number at the start position we are going to put, and then decrement this position. Okay, so that next time we will have a next insert position. Okay, so I pose. Else what we have to do, else we have to consider the end index. Okay, so again we have to consider end index. So here VCT rate, instead of start we are going to consider end index. So VCT end. Okay, and then in the similar, probably we can do this like here we can decrement this in position index at because it is common in both cases, in the if case as well as in else case. Okay, so okay, yeah, one more thing, we have to increment start, because here current element has been considered. Okay, and here we have to decrement end, because current end element is considered. Okay, we should prefer prefix over postfix. Then now, so I hope this should work. We have size n, we are decrementing end, we are incrementing start, and we are looping when I crosses start crosses end, and we are decrementing position, and we are uh, calculating the square and then putting it into the output array. So let's try to run for sample test case. Wrong answer. Why is that so? Oh, got it. So here we have to close this absolute function, and here we have to close this absolute function, and then this if. Okay, yeah. Let's try one more time. We have missed the bracket for absolute. Yes, our solution got accepted. Now let's try to run it for all the test cases and see if it is work by submitting the code. Hopefully it will work. Yeah, our solution got accepted for all the test cases. If you found the video useful, then please like it, share it with your friends, subscribe to my channel, and press the bell icon for future update. Happy coding. Thank you.